Hi everyone, how are you? Happy Sunday. Hope that you're doing well in your part of the world and so glad that we get to spend some time together with each other today, learning about neural networks. So today is going to be part two of neural networks. It's going to be really exciting to see um, how we make some advancements in our learning. I think we're going to build a lot on what we did last week for those of you that were here. And we're just going to have some fun with it. We're just going to keep on having some fun with neural networks. I am seeing all of my feeds on my screens. Everything is looking good. I think on Instagram, I need to move over just a little bit, maybe. Let's see if that fixes it. I'm a little off center in my Instagram. And also, new for today, I am going to be streaming in two formats on YouTube. So if you see me on YouTube, you're going to find my horizontal format, but then you're also going to find my vertical format. YouTube, for those of you who don't know, YouTube has really been pushing the vertical format recently. I guess they're feeling the pressure from some of the other streaming companies out there, but they're actually encouraging people to stream simultaneously in both formats. So if you're on the widescreen YouTube, you're just fine. I think that's the best format because I'm going to have some slides and code out there. But if you are on vertical, you can also catch me on vertical. If you're on Instagram, you're obviously seeing me in vertical, but on Instagram, you can also switch over to YouTube if you want to see a little bit of a widescreen view. But really happy to see everyone, really excited to be able to share another Sunday with you guys, just to see how we continue learning from each other and see where we end up with neural networks. So I'm already seeing people coming into the chat. Thank you so much. Really appreciate you. Feel free to say hello, introduce yourself if you'd like. I love that we're building a sense of community as always. So please, just feel free to say hello and tell us a little bit about you if you'd like. Yeah, so I'm already seeing the chats. I guess it's over here. I'm already seeing the chats. If you're on the vertical YouTube, you're probably not going to see the chats. And actually, I'm already seeing Leo. Leo, I see you on my vertical YouTube chat. You're welcome to stay there. You can also come on over to the horizontal. Leo, you might have missed that, but I'm streaming in two formats today. I'm streaming both vertical and live. So you're welcome to choose from one of those. All right, so looking at my chat from the very top, my good friend Starry Vibes. How are you, Starry Vibes? So good to see you. Hope you're doing well. Let us know how you're doing in your part of the world. Glad to see you here. Arman from Twitch. Awesome. So good to see the Twitch engagement coming back. I have a lot of followers on Twitch. No idea how they got there, but glad to see that you guys are there. Arman says, hi, big fan of your work. Thank you. Thank you so much. I appreciate that. Yeah, I don't know if I refer to you guys as fans. I just refer to you guys as people who I chat online with. But thank you so much for that, Arman. It's so good to see you. Leo says, I only see you on the vertical. How can I change? That's a good question, Leo. I guess you'd have to go to my profile page and then see, and then on my profile, I think I would have I would have two different streams listed. I think this is my first time streaming on both formats, guys. Okay, there's Leo. Okay. Sravan, so good to see you, my friend. Sravan says, hi, Dennis. Happy to be part of your session. Yeah, Sravan, welcome. Sravan, I also see you on vertical. Feel free to switch over to widescreen if you'd like. All right. All right. So Manoj, our good friend Manoj. Hello, Sir Dennis. Manoj from Hasaragata, Bangalore, India. Happy Sunday to you too. Hope you're doing well. Thank you so much, Manoj. Really appreciate you. I'm doing very well. It's Easter Sunday here in the U.S., at least for most people in the U.S., and doing very well. It's a beautiful day out. Took my dog out, so doing well. And now I get to spend time with you guys, so everything's going well. Everything is going well. And by the way, guys, if you see a little star next to Manoj's name, that's because he is one of the subscribers on my channel, or rather a member of my channel. So it does provide extra support. So if that's something you guys want to consider, really appreciate you. And I appreciate people like Manoj and his continued support. So thanks so much, Manoj. Next, Yassine. Hello, sir. It's Yassine from Tangier, Morocco. Yassine, my good friend. Glad you're doing well. Hope everything is good out there in Tangier. Let us know how you're doing. Always glad to see you and glad you're checking in. Thanks so much, Yassine. Denelson, another great longtime supporter, says, "Good morning, everyone. Greetings from LA, California. Hope everyone is staying safe." Yeah, Denelson, I think most people are doing good right now. And LA is always going to be LA, right? With the traffic and stuff. So glad that you're here, Denelson. Glad to see you, friend. Ty, hey Ty, how are you? Good to see you. Ty says hello, everyone. Nice to see you, Ty. Glad you're here. Let us know how you're doing, and hope you're ready to learn a little bit about neural networks. Is it Irfan? I think it's Irfan. Irfan says hello. Irfan, thank you so much for being here. You're welcome to stay on Instagram if you'd like, or you switch over to YouTube. Happy that you're here. Let me keep an eye on my Instagram over here. Osama, another good friend from Morocco, says, "Hi everyone, Dennis. Hope you're doing well." I'm doing very well, Osama. Hope the same for you. Yeah, I got up early. I get up early on Sundays. Well, I get up early every day. I went out. I had a little bit of breakfast. I took my dog to the park, let him run around all over the place. I go early because I don't. I'm okay with keeping my dog off the leash. So I let him run around. He can do whatever he wants, and then we go get some coffee and just hang out. So it's been a good Sunday. It's been a real good Sunday. CJ says, "Hello, Coach." Yeah, you know what? I don't mind being called Coach at all. I think that's pretty cool. Well, hello to you too. Hope you're doing well. Let me just keep on going down the list. So many people today. Wonderful. Brandon says, "Good morning. Got a pop-up this morning. So curious and wanted to check out the live presentation." Nice. Thanks so much, Brandon. Hey, I don't know where that pop-up came from, but glad you checked it out. Feel free to stay. We have a great community here. We're going to keep on learning about neural networks. When I stream on Sundays, I usually do a series, like an educational series over multiple weeks. So today is week 2 of neural networks. I've got some materials set up for us, so I think we're going to have a good time. So thanks for being here, Brandon. Naren, is it Naren? Yeah, hi, I'm Naren. I work as a data scientist, but I don't feel like one, very unconfident. So Naren, the best thing I can tell you is that you are not alone. As many of you know, I offer personal coaching, and that is one of the most common issues that people come to me with. Some people who express this, maybe they have a degree, but they don't feel very confident, or they feel a lot of imposter syndrome, or they feel trouble adjusting to how they did things in school versus how they're done in the real world. So Naren, I hear this a lot. So you're not alone. It's a very common problem. And also, as I've told you guys before, I hear it on the business side. I have friends who are hiring managers who tell me that, who tell me, "Hey, I hire these people with these degrees and they don't know anything," or I hire them with a master's, but I really want to hire them as a summer intern because like that's their level of knowledge, right? Like they don't have any advanced knowledge, right? So you're not alone. It's a common problem in the data science industry, I guess we could say, right? So hang around, keep on coming back. You're gonna learn from the community. And if you're interested in personal coaching, I also offer those links on my profiles. But very common problem that you're describing there. And so don't worry, you're not alone. You're gonna be okay. All right. Naren says, "Big fan of you." Thank you. I appreciate that. Yeah. I'm coming up on a year, guys. In 10 days, it'll be a year since I started doing this. Crazy. Leo says, "I'm here." Well, I'm glad you're here, Leo. Leo, our good friend from New York City. Leo, glad you're here. Such a great contributor, such a great supporter for most of that year. Really appreciate you, Leo. And Leo is also one of our moderators. So, it's a volunteer position. So please make sure you give Leo thanks because, it kind of helps me keep the chat clean and all that. So glad you're here, Leo. Armand on Twitch says, it's inspiring that you share your wisdom and experience with all of us here, and we appreciate it, sir. Thank you. I appreciate that. The whole reason I started was to put out good quality data science materials. That's all I want to do. That's all I want to do. I'm tired of the nonsense that's out there. I'm tired of people producing these I'll make you a data scientist in 3 months type of nonsense, because that cheapens my profession, right? Like, this is what I do. This is my profession. This is what I dedicated my life to. So I don't want people cheapening it, right? So I'm here to give you guys good, honest information. I don't think I've ever done it to you, and I definitely try to not lie to you guys, right? So I'm just going to give you the best information I can. So thanks for being here, Armand. Is it whale? I think that's pronounced whale. I used to have a coworker with the same name. I think it's pronounced whale. Let me know if I'm wrong. But Whale says hi from Egypt. Very cool. Hi, Whale. How are you? I'm telling you guys, I'm big in North Africa. I get a lot of viewers from Morocco, Algeria, Egypt. What's another North African country? Can't remember. There's a couple others that my analytics say I get a lot of viewers from. So Whale, welcome. Glad you're here. Let us know how things are going in Egypt. I imagine it's getting a little bit warmer in that part of the world. But glad you're here. Thanks for coming. Khalif says, hello, Sir Dennis and everyone. Hey, Khalif, how are you? I don't think it's your first time here. I think you've been here before. But so glad to see you. Glad that you're here. And anything we can do to help, just let us know. All right. Anybody else who wants to introduce themselves or anything else? Okay, Whale, I see you over on Instagram. Okay. And it is pronounced Wael. I think, is that it? Wael? Hi, I'm from Egypt. I found your first video on YouTube, and it was an eye-opening one. Thanks a lot for the simplification. Okay, do you remember which YouTube video it was? Was it this series from last week? Let me know. I'm curious to know which one was the eye-opening one. I'd like to think they're all eye-opening. Thank you very much. But let me know which one it was. I'm curious on which one inspired you to join us today. But yeah, guys, I try to be honest with you guys on how much skill it takes to be a data scientist, right? That's part of what I do. But at the same time, I try to not make it intimidating, right? I try to make sure that we keep it very reasonable, very achievable, right? Because data science can be intimidating, but that doesn't mean that it's impossible to learn, right? I mean, I think most of you guys are very capable of learning it, right? It's just got to put the time in. You got to put the time in, and you kind of just have to see things in a different way, with a different perspective, right? So that's what I'm trying to do, right? And we're going to try to keep on doing that today with the second part of our series, okay? So Wael says, yes, the first one of this series. Okay, cool. Thank you so much. Appreciate that. So give me just a second here, guys, to clean up my desktop. I'm looking at the vertical. The vertical chat has slowed down. Okay, that's great. All right, guys. So who's ready to continue talking about neural networks? If you still want to introduce yourself, go ahead and do that. But otherwise, I think I'm going to start prepping my desktop. And we are going to get started. And just like last week, we're going to try to keep it interactive. Try to keep it, asking questions. So be ready to participate in the chat and see where we end up, guys. So got that. All right. Part 2 of neural networks. What I want to do is I want to start with a review, and then we're going to talk a little bit about the code goals that we want to achieve today, because we're going to keep on learning a little bit about neural networks, and then we're actually going to do some code creation, right? We're actually going to start coming up with code. But just like we did in other series, and I think in all of our series, we're not going to write the code ourselves. We're going to use AI to help us with the prompt. Well, we're going to prompt AI to help us with the code, and kind of see how AI can also guide us, right? Because that's all based on the premise that the data scientists of the future will be heavily, heavily aided by AI, right? If you're starting from a blank screen in the future and you're a data scientist, you're probably doing it wrong, right? So we're just going to kind of keep on building on that, right? Okay, so one thing I want to get clear from the very, very beginning is you guys know that I'm a big fan of this book, and a lot of this series and some of the charts you're going to see today, I'm drawing from this book. Now, I want to be upfront with that because I want to be intellectually honest. You know, I'm not trying to steal anybody's work. You know, I'm very inspired by this book. As I told you guys, this book really helped me in my learning. So I want to be clear that I am pulling some inspiration from this and I am pulling some charts from this. I'm highly encouraging you to go out and get this book and work through this book. But just want to be upfront with that, I'm not, I'm not trying to steal anybody's intellectual property. I'm very inspired by the book. And I'm kind of going in the same order that this book does, because I think that the order it does, it's very, just very logical, right? But at the same time, I'm building upon the work, right? We're going to be doing AI. This book doesn't really have any AI. We're not going to be using any of the code from the book. So highly encourage you to go out and get this book. And I'm just putting it out there because I want to be intellectually honest about this, okay? All right. So what's a neural network, right? We talked about this last week, about how if you're new to data science or if you're new to neural networks, you know, maybe you know other models, but not neural networks, it can be kind of intimidating, right? Like the word alone can be intimidating, right? Like neural networks, like, whoa, that sounds heavy, right? So this is it. This is all a neural network is, right? It's a mathematical representation of how the human brain works. That's it. That's all it is. And we talked about that, right? So if we're going to say that it kind of mimics the human brain, then let's understand the human brain a little bit, right? And we basically talked about how there's these cells all throughout our bodies. There's a flow of electricity, you know, from left to right in this case. There's some sort of an input, and in the majority of cases, it's multiple inputs. It travels along the cell itself for some processing and thinking. And then it goes out to these terminals, which basically go out to other outputs, right? And also it's more often than not multiple outputs. So you have multiple inputs coming into the cell. The cell makes some sort of decision of fire or not fire and sends the information on, right? So again, if I'm lifting my hand, there is a collection of cells that are starting from my brain, sending electrical impulses down my neck, down up my arm, and that chain causes my arm to go either up or down, right? And then on this side of my body, nothing is happening. There's nothing firing because there's nothing being sent there, right? Nothing is being asked to be activated, right? So a simple network like this is a representation of that. Here are your inputs. You can have multiple inputs. Here are the additional cells where the information or the pulses travel. The cells do some sort of processing, or rather the nodes do some sort of processing. They decide whether they're fire or not fire, and they go on and they send it to subsequent cells. In this scenario, this is a very simple neural network with only one hidden layer, but you can have any number of nodes and any number of layers. It's really just kind of up to you, right? It's kind of, that's one of those like just general architecture decisions that you make on your own, okay? But that's it. That's all a neural network is. It's just a mathematical representation. Each one of these nodes represents a cell. Each one of those nodes does some sort of processing to help decide what happens when, and you just kind of go on from there, right? We also talked about this processing that I keep on mentioning. There's a name for it, and the name is activation functions. So each of these nodes has an activation function that takes in some inputs, runs through the function, whatever that function may be, and gives a result. And based on that result, the node or the cell does or does not do something, right? So, audience participation time. What were some of the challenges that we talked about with neural networks? Let me know in the chat, because there are some challenges in working with neural networks. And even if today is your first class, even if you didn't attend last week, you can probably guess at some of those, right? So let me know. What do you guys think? VK says, where's the screen? So VK, right now you are watching on my vertical feed. I'm streaming both vertical and horizontal or widescreen. So feel free to click on my profile and you should see two streams listed, and you'll be able to see my screen on that one, okay? So guys, let me know in the chat, what are some of the challenges in working with neural networks? Okay. CJ is already putting up poor interpretability. Yeah. Yassine says vanishing gradients, interpretability. Cool. So who remembers what vanishing gradients are? We talked about this. Who remembers what vanishing gradients are? Can somebody describe vanishing gradients? Osama says needs large data and interpretability, difficult to understand decisions. Yep. Yep. Doodle, what a great name. Doodle Dad Lifts says explainability, not being able to explain to stakeholders. Yep, yep. Denelson says memory. Yep, definitely. Mooey time? Moo time, welcome. I think it's your first time. Welcome. Glad to see you over on Twitch. Moo time says values get closer to zero. Moo time, let me know. Was that a answer to vanishing gradients? Or Moo time, let me know. I think you're trying to answer vanishing gradients, but let me know. Anaran? Is it Anaran? Anaran says, how do you choose the right activation function? We're going to get to that. Great question. Great question. I love that you guys are headed in that direction, right? Because that is the next question, right? Like, activation functions sound pretty important. We should learn about them, right? So Denelson says, vanishing gradients is when the products or neurons get so small they become zero and inactive. Yeah, yeah. And Mood Time says, yes, that they were asking for, or they were answering for vanishing gradients. Yep, yep. Starry Vibe says, is it gradients become too small or too large, making training unstable? Ooh, okay. So Starry Vibes is asking an interesting question. When we're talking about vanishing gradients, are we talking about values becoming too big or too small? Let me know in the chat. You don't have to give me an explanation. Nobody's going to call on you. Just give me an intuitive answer. Is it because they're getting too big or too small? Manoj says runtime. Manoj, let me know more about that. What do you mean? I think you're on the right track, but give me a little bit more information. Yassine says requires good data pre-processing. Oh, that's a good one. That's a good one, guys. Nobody's mentioned that before. I'm going to come back to that. But yes, Yassine, remind me of that if I don't come back to it. But yes, we definitely need to talk about that. Denelson says exploding gradients is the opposite of vanishing gradients. So the gradients get so big. Okay, cool. I love the explanation, Denelson. Wael says not knowing how they behave. Okay. Yassine, Ty, and Denelson all say too small for vanishing gradients. Yep. Brandon says vanishing gradients means that learning of the network slows down because the weights become small. Yeah, Brandon, but it's not just slowing down, it's that it becomes ineffective. Right? So guys, all of you are correct. Vanishing gradients are basically gradients that become so small that they approach zero. And why would they do that? Well, because a lot of values and weights that we're going to be dealing with are not big numbers to begin with. Typically, they're decimals, right? And what happens when you multiply a decimal by a decimal? It gets smaller, right? Decimals times decimals just results in a smaller decimal, right? Smaller and smaller and smaller and smaller, the more you multiply, 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 right? So Brandon, it's not that they slow down, it's just that they're like everything just becomes zero. And then it just becomes zero times zero. So in a way, it can kind of become a little faster because it's a simpler calculation. But yeah, I mean, you can basically nullify all of your work just because you have so many layers, so many nodes, so many inputs that you're just calculating yourself to death, basically. That's the vanishing side of it, right? Shashank over on Instagram, how are you? Says, hey, how are you, sir? I'm doing great, Shashank. Glad to see you. Welcome to stay on Instagram, or you can switch over to YouTube and join us on the widescreen. So Moo Time or Moo Time says, I think it's because they are getting too small since called vanishing. Yep, that's exactly right. That's exactly right. It's kind of built into the name, right? Khalif says, sometimes optimization gets messy. Have to try different techniques. You're not wrong, but Khalif, isn't that a function of any model? Like you just described data science, not necessarily neural networks, right? Like we should want to optimize and streamline all of our models, right? Even if it's just like a gradient boosting model or something, right? So what do you think? Like what you described is not wrong, but it's not exclusive to neural networks. I guess is what I'm trying to get you to think about, right? Manoj says problems that occur during the execution or deployment of a neural network model. Yep. So Manoj is bringing up a good point, and I still see the answers that are in my chat, and I'm going to come back to those answers. But let me take a little bit of a detour here, because Manoj saying that the problems that can occur during the execution deployment of neural networks is very key, and it allows us to circle back to Yassine's previous statement about pre-processing. What are some of the challenges? Let me know in the chat. What are some of the challenges around pre-processing and deployment that also happen to neural networks, that are unique to neural networks, right? Because you have to be careful in any data science deployment. But there's some that are unique to neural networks. Or what does Yassine mean when he talked about pre-processing overall for neural networks? Let me know. What do you guys think? I'll give you a hint. Remember that I said that your nodes are mathematical formulas that take in inputs, right? What about text? Can a node take in text? How do you multiply text? How do you multiply pixels in an image? Right? Let me know. What do you guys think? Manoj says data quality issues. Manoj, that can be in any model, right? Any model has that. CJ says you mentioned tokenization last time. Yep. Okay. So you're on the right track, CJ. What is tokenization and why do you need it? Why did tokenization come up in our same discussion as neural networks? So give me a little bit more, right? Yassine says different input size. Yeah. That's a concern, right? Text doesn't always have consistent input. You can have sentences with any number of lengths and characters and words, right? Brandon says, for neural networks, you have to be careful that you do not introduce future conclusions, outcomes, merge into training data. I think this is called leakage. Brandon, is that unique to neural networks though? I feel like that would apply to a lot of models though, right? Let me know, Brandon. Maybe I misunderstood your statement. But remember, we're trying to focus on things that are unique to neural networks. Denelson says text needs to be tokenized and pixels need to be processed into the RBG values. Yeah, why, Denelson? You're so close. You're so close, my friend. Why? Denelson goes on to say tokenization gives text values that can be interpreted by the model as numerical values, and it can change the importance of a word or phrase as it trains. Yeah, yeah. So I think the portion I want to highlight in your answer, Denelson, is about the numerical values, and that's really the answer we're looking for here, guys. Remember that neural networks, it's all just numbers based, right? You can't multiply text, you can't multiply a pixel, but you can translate it into numbers. And that's what tokenization is, right? Tokenization is a numerical representation of text, right? So you can do that. And same thing for like pixels and images, right? How do you convert an image to something a neural network can understand? Well, you can extrapolate out the RGB values, right? So that's really what we're looking for. So let's take it all one step further, because who was it? Manoj mentioned the deployment, right? So what happens if you used pre-processing during your training phase? What do you need to do when you go to deploy an algorithm? What do you need to do when you go to deploy it in a production or runtime or prediction time situation? What do you guys think? I'm going to come back to some of the previous chats that I skipped while you guys think about that. VK says interpreting becomes difficult. Yeah, absolutely, VK. A couple of people have mentioned that. And interpretability with neural networks is not great. They're not known for being interpretable. I know. Somebody's out there sitting, but neural networks are much more interpretable now than they. I know that there's additional tools and additional techniques that make them more interpretable. But from a learning perspective, like a history perspective, you should know that neural networks have kind of had this knock on them that they're not very interpretable. Brandon says, does this also have to do with gradient descent, where we have multiple local minima, and in this case, the steps become smaller and smaller, and like you say, converge to zero, and nothing is learned? Yes, Brandon, you're on the right track with that. The only thing I would add is that the multiple local minima is a problem that can happen at other times also. It's not exclusive to vanishing gradients. But yes, it can definitely be a side effect of that. So you're on the right track with that. Denelson says speed can also be an issue. Yep. Yeah, so here I want to remind you guys that neural networks are not fast to train, and they can also be slow at runtime, right? So you guys know that I'm not very bullish on self-driving cars, right? I think that we should be more cautious than we are about them. And this is one of the reasons, because most of those cars, most of that technology does rely on neural networks, and neural networks can have a lag time to them in their responses, right? Obviously, you can fix that with hardware, with the quality of the neural network, the way it's implemented, so on and so forth. But neural networks can add lag to your decisions, to the speed that you need things done at. So yes, Denelson is right. Speed is an issue. Just remember that it's an issue for both the training side and the actual runtime side. Okay. Wael says overfitting and underfitting. Yep. But again, that can happen with any model, though, right? You can overfit a regression model if you try, right? So you're on the right track, Wael, but it's not exclusive to neural networks, right? Let me pick up where this goes again. Yassine says different data types. What do you mean by that, Yassine? I'm not sure I understand that. Because the pre-processing should take care of that, in the sense that you're only going to have one data type, and that's going to be long values, right? Which are usually decimal values. But yeah, so let me know what you mean. You see, maybe I'm just not understanding. Manoj says yes, tokenization converts text into numeric. Yep, absolutely. Very important step in in neural networks. Khan says, "Hey Dennis, how are you? I'm doing great, Khan. How are you? Hope you're doing well. I see you over on Instagram. You're welcome to stay there, or you're welcome to join us on YouTube for the widescreen. Okay." I think it's Umair. Umair on my vertical stream is asking, "Do neural networks have a functional form?" Um, Umair, let me know what you mean by functional form. Can you describe that a little bit more? What does functional form mean to you? I want to make sure I understand your question first. Let me know what that means to you first, okay? Brandon says, isn't a neural network limited in the number of layers and nodes? Would that represent a limitation of how accurate one can be? Ooh, great question, guys. Great question for the chat. So, Brandon is asking, is a neural network limited in the numbers of layers and nodes? What do you guys think? Let me know in the chat. You only have to give me a yes or no if you'd like, or give me an explanation if you'd like. But Brandon's asking an excellent question here. What do you guys think? Is a neural network limited in the number of layers and nodes? What do you guys think? Good question. So Moo says, since neural networks use math to mimic the human brain, so we need tokenization to be able to use math. Yeah, absolutely. Tokenization, very, very key part of data science, or of neural networks. So Moo goes on to say, we need to make sure that we use the same tokenization when training and deploying. Yes, that's exactly right. And Moo, I wouldn't say same tokenization, it's the same data pre-processing, because pre-processing also applies to image work, right? To computer vision work. Not tokenization, obviously, but the same pre-processing you do there has to also be done on runtime, right? So what happens if you use a tokenization file during training, but you use a completely different tokenization approach or dictionary on your runtime? You'd have wildly inaccurate results, right? Or same thing for your RGB values. If the way you process them in training is different than runtime, bad things are going to happen, right? So that's really what I want to impress upon you guys, that it's all about the maintaining verity between your pre-processing during training versus what it looks like at runtime, okay? Very, very important part. Wael says, could need a huge amount of data as the neural network gets deeper. Yeah, but I think a couple people have mentioned the data. I think Osama mentioned the data requirements. Yeah, absolutely. Yassine says, yes, it was an answer to why pre-processing is needed. Let me make sure I remember different data types. Yeah, so Yassine, it's not that it's different data types, it's that it's not numerical. Text by its very nature is not numerical. So really or same thing for images, right? Images aren't numerical. So really that's why we need the data pre-processing, because otherwise the neural network doesn't know that. You can't multiply, words by words, right? So it's more about, it's not the different data types, it's that it only supports numbers as inputs, right? Jaya over on Instagram says, hi, sir. Hey, Jaya, nice to see you. Hope that you're doing well. I'm glad to see so many people on Instagram today. That's wonderful. All right. Okay, so coming back to Brandon's question, Yassine is answering, no, it's not. We can choose the number of layers and nodes as we want. Denelson says, no and yes, it is limited by the amount of memory you have, but hypothetically, it does not have a limit. Diffio over on Twitch, welcome. I think it's your first time. Nice to see you. Diffio says, Neural networks are limited in size, not in theory, but very much so in practice. Okay, Diffio coming in strong with their first answer. That's a great answer. So Diffio, Denelson, Yassine are all providing answers for Brandon's question. And all of them are correct, right? There is no limit on nodes, on the number of layers and the number of nodes within those layers. And if you remember, last week we kind of talked about how I kind of stopped short of calling them a hyperparameter, but you can kind of say, like, hey, I'm gonna play around with the number of nodes and layers to kind of see if I can improve my results. Like that's a valid way to construct these, right? There are dedicated hyperparameters for neural networks, but the architecture itself of the network is something that you can play around and experiment with. So Brandon, that's basically the answer. That no, there is no limit to layers and nodes. It can be your network architecture can be whatever you want it to be. Now Diffio here is correct, and some other answers I've touched upon. And I think Denelson mentioned speed, but yes, they are limited in practice because the bigger the neural network, the more time it takes to train, the more processing power you're going to need. The slower it is at runtime. We talked about some applications where you don't want a slow neural network, right? You might need very high speed neural networks. So no theoretical limit, but from a practical perspective, you might have to go with a smaller neural network than what you would like to otherwise. Okay? Starry Vibes. Oh, okay. Sorry, Starry Vibes. I missed your answer previously, but Starry Vibes contributing to the same answer says no. It just depends on your needs and the resources you have available. Yeah, that's a very, very practical answer. Yeah. Moo says, I think we have as many nodes as resources allow. Excuse me. However, whether it is needed depends on the problem, I believe. Yeah. Yeah. And I guess it's really not, well, it is depending on the problem in the sense that what gives you the better results, right? Like that's really what it is, right? Like that's really like the main driver, right? Okay, so Anna says, what kind of number is the tokenized word converted into? Is there a standard function applied to the word to convert it to a number? Okay, great question. So Anna, here you're kind of talking more specifically about like NLP related work, but when it comes to NLP, one of the first things you're gonna do is you're gonna tokenize your text, and it's basically just taking every word and assigning it a number. That's all you're doing. Every possible word, you're assigning it a number. So as you can imagine, the token dictionary, and it's usually referred to as a token dictionary, by the way. So as you can imagine, the token dictionaries can vary in size, and they'll definitely vary by language. But for example, in the English language, it's commonly accepted that there's about 20,000 words that are used in the English language. I think the total number is like 35,000, 40,000, but like in day-to-day conversations, it's like 20,000 words. So most dictionaries use that as like as a starting value, I guess you could say. And yes, there are some standard dictionaries out there. For example, a lot of the tutorials you're going to come across, or maybe stuff in your schoolwork, is going to mention NLTK, right? The Natural Language Toolkit. That's a toolkit that was put out, I believe that was put out by Meta or some engineers at Meta. So they have their own dictionary, their own tokenization. There are dictionaries that are based on social media that will take common words in social media. There are dictionaries that are based on Wikipedia, where they'll take kind of like all the words that you'd find in Wikipedia and tokenize those. And then beyond that, you get into some of the vectorization libraries or vectorization values. So the Stanford NLP Lab has put out some of those dictionaries that are popular for that, or vectorization libraries that are popular for that. Um, I think that one is WordNet. So I'll stop there because my intent is not to make this an NLP discussion. But yes, there are standardized libraries out there, or you can make your own. So like NLTK gives you the ability to make your own, right? Because you might be working in a domain that has particular words or particular lexicon that is important to that domain. So it just kind of depends on the application that you're working on. But yes, there are like, widely accepted general libraries that are out there. Okay. And we'll get to that if we just ever decide to have like a dedicated NLP series. But yeah, I mean, that's just the quick answer. And I kind of don't want to go beyond that because again, it's really not my intent to do NLP. It's really more about neural networks in general. Okay. Manoj, yes, word to vector. I think word to vector is the Stanford one, and then WordNet, I believe, is put out by other people, if I remember right. But yes, word to vector is the Stanford one. Thank you so much, Manoj. Brandon says, "Thank you for the insights." Yeah, you're welcome. Just trying to give you guys the best information I can in the best format that I can. I know it's your first time here, Brandon, but this is kind of how all of my Sunday series go, or at least I try. At least I try to make them go like this. Uh, so Denelson also agrees with word to vector. Yeah, I think word to vector is the Stanford one. If you guys want to know more about this, just Google Stanford NLP Lab, and they have plenty of materials on their website. Okay, so let's keep going. So, where do neural networks fit, right? And I want to give you this chart again, guys, because for me, this is kind of like the progression I have in my mind as far as like the different tools that you could be using or the different ways you could be working with well, I mean with kind of data science in general, right? You can start out with statistics, and then that leads to analytics, and then you go on to machine learning, and then you kind of work with neural networks, right? And I shared the story with you guys that you know, you can pick up machine learning, with tutorials and models, the ISLR book, which is basically a machine learning book. If you're interested in that, you can find my series on my channel. But to me, my learning like really took off, really like started blowing my mind when I started thinking about neural networks. Like when I read that book, I told you the Tariq Rashid book, that's where I thought like, oh, okay, this is why data science is so like powerful, right? When I started doing that, it was like, oh, okay, I get it now, right? So obviously you can go beyond this into AI and things like that, but then again, most AI is based in neural networks. But this is kind of like the stack or the progression that I would ask you to kind of keep in your mind as far as how these tools are all kind of relate to each other. Okay. So over on my YouTube vertical, I see Lallman. Lallman says, hope I wasn't too late. No, of course not, my friend. So Lallman, you are on my vertical live. You're welcome to stay there or come join us over on the horizontal, which is where you usually join us. You can probably click on my profile, and it'll go to it should show you two live streams running at the same time. Okay. And actually, you know what? I kind of want to verify that real quick. So give me just a second here, guys. I kind of want to check that on my own. Yeah. So I'm looking at my own YouTube page, and it is showing me as doing two live streams, and one of them I've called the vertical stream. So Lallman, right now you're on my vertical stream. You're welcome to join me on the widescreen. Okay. Okay. Lallman is back. Lallman says, I was confused why you decided to go with the vertical one. So Lallman, that's a good story. Good question and a good story. So because of my success due to you guys, and I really appreciate all of you for this. My channel has grown quite a bit over the last year. I do have my little YouTube plaque back there. So because of that, YouTube has like sent me these invites to participate in these boot camps and like these like trainings, I guess you could say, for creators. And I have a what's it called, a community manager or something like that. Like they're supposed to be like my helper at YouTube, like if I ever need something. Um, and one of the things that YouTube has been doing over the past like 2 months is they've really been encouraging people like me to use the vertical format. They're really trying to have many, many more vertical live streams. I guess because, they're comparing themselves to TikTok maybe, because TikTok obviously has a lot of vertical streams, so many more than YouTube. So they're kind of like encouraging people to do that, and they're encouraging people and saying, well, you can stream on two things. You can stream both horizontal and vertical if you want, which is kind of weird because like I don't think any other platform lets you do that, like run two streams at the same time. But that's how much YouTube wants you to do it, because like they're really encouraging people to do it. So I saw that this morning. They sent me a note about that this morning. And I thought, I'm going to try it. It can't hurt. I've never streamed twice like that. So that's what I'm doing. So yeah, so if you go to my profile, you're going to see two streams. You're welcome to stay on the vertical or the horizontal. It's up to you. But anyways, just giving you an answer there, Lom, just to help you guys understand why I'm doing that. I'm enjoying the YouTube ecosystem. I got invited to one of their little get-togethers last month, which was a lot of fun. Like I said, I have like this contact at YouTube, so if something ever happens, I got like my own little personal tech support, which is nice. But just trying to see what the vertical offering on YouTube is like. All right, so getting back to the materials, this is new material, right? This was not in last week's deck. So let's talk about nodes, right? Because as I think has become clear to everyone, like nodes are pretty critical in the whole like study of neural networks, right? So again, being open and honest, I'm pulling this from the Tariq Rashid book, right? Very good book. Highly encourage all of you to pick it up. And this is what we're doing, right? We have two inputs, a 3 and a 4. There's some sort of calculation that happens in the center, and then there's some sort of output. That's it. That's all it is. If you do this across multiple nodes and multiple layers, you have yourself a neural network. That's it. That's all it is, right? So if you can see that, right, there's inputs, calculations, and outputs. What happens when an output is incorrect? Have we seen other models when an output is incorrect? What do you guys think? What happens if you were to have this calculation node and the output was 10? What would we do in that scenario? What do you guys think? Let me know in the chat. I mean, we kind of have to do something about that, right? What do you guys think? Anna says the loss function comes in. Yes. Yassine says we need to adjust that calculation. Yeah, that's right. Right? I mean, that's really the answer, right? we would need to adjust. And we would need to say, well, wait a minute, we need to kind of retrain, right? Something has gone wrong in our training, and this calculation in the node is not correct. So we need to adjust that, right? Manoj says, matrix multiplication gone wrong within the nodes. Yes, but the matrix multiplication is more about the training, right, Manoj? Starry Vibe says it will come back. Starry Vibes, I'm going to take that to mean that you mean that it's going to be retrained, and yes, that's correct. Speaking of retraining, Osama and Denelson are both mentioning back propagation, which is arguably a form of retraining, or at least revisiting the calculation. Yeah, yeah, but you're exactly right, right? Have we seen this in other models? I know many of you have been here for a lot of my live streams before. Some of you are new. That's okay. But have we seen this with other models? What do you guys think? Yassine says yes. Okay, tell me more about that, Yassine. Because you're right. We have seen other models. Tell me more about that. Where else have we seen this? Lallman says gradient boosting. Yeah, yeah. Anywhere else, guys? Where else have we seen this? Where the model output is incorrect? What do you guys think? Yassine says there are many models that use gradient descent in their process to adjust their parameters. Yassine says, as in simple linear regression. Yeah, yeah. So look, the whole purpose of me asking this of you guys is to realize that the way that we handle the training and the process of a neural network is not much different than what you already know. Again, I'm just trying to take like the mystique out of it, because I think so many people kind of get like caught up in how complex neural networks can be, but it's the same. It's the same as other items that we've seen before. It's going to make errors. You're going to go back and you're going to adjust, and you're going to go back and you're going to try to improve on your previous model. But overall, it's the same thing. Okay? So that's all I'm really trying to impress upon you here. That yes, you're going to have nodes that make incorrect calculations, but that's okay. You're going to fix them in the same way that we've tried to fix other models before. It's really no different than that. You're going to adjust your weights. Sometimes you can adjust your input, and then you're going to see what downstream effect it has, on your results, and you're going to go from there, right? Just as Yassine says, just as you would in a simple linear regression, right? So speaking of which, what measures, let's build upon that, right? What measures did we use for model evaluation in the past? And also, what is a ground truth? I know most of you are going to know the answer to the second question, but I just want to establish a common understanding here, right? Or there could be some people that are also newer in the chat, right? So what did we use for previous model evaluation? Because we just agreed that we're going to fix the model in the same way we fixed other models. So can't we use the same evaluation metrics? Right? So what are they? And what is a ground truth? What do you guys think? MSE, and a ground truth is a recorded expected prediction from the data we collect. Yeah. Yeah, I think MSE is a pretty good example of what we've used in the past, but it's not the only one, right? So feel free to suggest other ones out there if you want, chat. But what are some of the metrics that we've used? And a ground truth is a recorded expected prediction from the data we collect. And that's true, right? A ground truth is basically what happened in real life. Not what we think would have happened or what the algorithm said was going to happen, but what actually happened in real life, right? So Yassine says, for regression classification, we have accuracy, precision, and recall. Yeah. And yes, we can use the same metrics. Manoj says, agree with Yassine. Yeah. Yeah. You guys are all on the right track, right? And that's exactly what we're looking for here. That regression, accuracy, precision, and recall are going to be as useful here as they were in other models. So that's exactly right. That's exactly right. Okay? That's what we're looking for, right? Again, we're just trying to take the mystique out of it. We've talked a lot about nodes and layers, and we're going to see some code today, and we've talked a little bit about math. But it's the same thing. It's the same metrics that we're looking to work for ourselves, okay? So I'm going to jump ahead here because I already see some of these answers in the chat. What are we looking at here? What is this? And if you guys want extra credit, who wants to take an explanation? Give me an explanation in the chat for precision and recall. But here's the thing. Talk to me like a business person. Don't give me that math geek talk. You guys know I don't want you guys talking like math nerds out there. Give me the business explanation. I'm your managing director. Tell your managing director what the heck this precision and recall thing is. Go ahead, guys. That's a challenge for the chat there. What is precision and recall? And talk to me like I'm a 10-year-old like I'm a 10-year-old managing director. Because there are some 10-year-old managing directors out there. So what do you guys think? And if you don't know what we're looking at there, that's okay. You should know that what you're looking at is going to be a common a common theme throughout your data science career, right? This isn't exclusive to neural networks. But what do you guys think? Okay, so Sravan says, how many times are we predicting correctly? Okay. Give me a little bit more to that, Sravan. You're on the right track, but I think we need to go a little bit deeper. So Denelson says, precision is how many it got right overall, and recall is how much it is able to remember accurately. Precision is how many it got right overall, and recall is how it was able to remember accurately. Denelson, I'm tempted to give you a pass on the first one because you're not wrong, but I would ask you, didn't you just give me the definition for accuracy and not precision? And for recall, I'm not on board with the answer. I think the answer goes a little bit deeper. So take a think on that, Denelson, and come back, okay? Anna says, precision is how good the model is at correctly labeling the object as the original. Recall is how good it is at finding an object. Recall is how good it is at finding an object. Okay. I'm on board with the precision. The recall, I don't know. I don't know about the, I don't know. And also, by the way, if somebody wants to just give an idea of what we're looking at for some of the newer people or whatnot, just feel free to tell me what we're looking at in the graphic, right? Um, is it Rexman or Rockman maybe? Welcome. I think it's your first time, so welcome to the stream. Rockman says, precision tells all of the times our model predicted something is positive, and how many of those are actually correct? Yeah, yeah. But tell me like I'm a managing director, right? But you're on the right track there. Yassine says it's a confusion matrix. Yeah, yeah. So for those of you that are kind of confused on what's going on, or maybe not, maybe you're early in your studies, this is a confusion matrix. This is what's known as confusion matrix, and it helps us understand what our algorithm predicted versus what actually happened in real life or our ground truth, right? And by looking at how often the algorithm was actually correct in predicting what actually happened, or predicting the failures or the other classes versus what actually happened, you can come up with additional measures, right? You can come up with your accuracy, your precision, and your recall, right? So that's kind of what we're working through here. Okay, Yassine is going for the examples. I love it. Yassine says, we have two scenarios for some cakes we're cooking. Either the cake is good or overcooked. Precision is from the one that are good. How many are actually good? Recall is out of all the overcooked. How many did we identify? Okay, Yassine. I think we could massage a couple of words in there, but I think you're on the right track there. I'm on board with it. Starry Vibes says recall is the proportion of true positives identified among all the real positive cases, and precision is the proportion of true positives among all the total positive precisions. Do we reflect the validity of the predictions? I don't know, Starry Vibes. I could be misunderstanding you, but I don't know if I'm on board with this. It almost feels like you're describing the same thing twice. I don't know. Rockman says recall tells out of all the positive cases how many that our model correctly find. Rockman, I'm looking back at your definition of precision, because I'm not seeing enough of a difference from your recall and precision. I'm jumping ahead here because it's catching my eye. Diffio says recall is about not missing opportunities. Okay, Diffio, I think you're on the right track. Tell me more. This is great. I'm glad we did this exercise because sometimes it's very difficult to express. Because I'm positive that all of you are smart and all of you know how to use these, but being able to express it properly is kind of like it's actually difficult, right? And I'm asking this because this is a popular interview question, right? Tell me the difference between accuracy, precision, and recall, right? Now, in those cases, you're probably explaining it to a technical person, but you're also going to be explaining it to your management, right? I've had to explain this many times in emails and phone calls and meetings. So it's good for us to go through this. Okay, so Osama says, precision answers the question of all the positive predictions I made, how many were actually correct? Oh, I love it, Osama. I love it. So give me recall. I think you're on the right track there, Osama. CJ says, recall. Out of all the customers we predicted that 20 would subscribe rather than the 50 that actually subscribed. Okay, CJ, I love that you're putting it like in real terms. Take it one step further. Why would you need this number? Because you're giving me a good example, but I don't understand why I would need that number. Right? And I want you to think about Diffio's answer about not missing opportunities. Because you're right there. You're right there, CJ. All right. Denelson says precision is how many predictions our model gave are right, and the recall is how many of our ground truths we were able to predict either accurately or not. Okay, cool. Okay, Denelson. I like it. I like it. Maybe a little bit still too technical for a managing director, but I like it. You're on the right track. Okay, so Diffio says recall is not about is about not missing opportunities. Uh, of all the customers who actually wanted our product, how many did we correctly identify? It has a cost. Great answer, and that's exactly it, right? So CJ, coming back to your answer, it's not about the 20 who would subscribe. It's about the 30 that you missed, right? Because you could say that your algorithm missed 30 people that did subscribe that you should have predicted as subscribing but didn't, right? So Diffio, I like the way you're putting this, right? Of the actual ground truths that happened, how many did we anticipate happening, right? Because that is important in most algorithms out there, right? Because if not, that means you're missing out on opportunities. You didn't correctly identify people, places, things that you should have targeted when your algorithm told you to not target them, right? Okay, so Anna says, I'll take another stab if you don't mind. Feel free, Anna. Feel free to keep the answers coming, guys. You guys can answer anytime you want. If a model detects 100 objects and only 80 correct, that's 80% precision. If there are 100 ground truths and the model can only detect 70, the recall is 70%. Yeah, I like that. I like that, Anna. You got to put it into business terms for most managing directors, but you're on the right track there. Yeah. Okay, Osama says recall. Of all the actual positive cases, how many did I correctly identify? Yeah. All right, I love it. You guys are. We got to an answer, chat. Right? We kind of felt around different things, but I'm glad how the chat kind of converged on an answer because I think you guys are basically there. So Lawman says, precision is out of all the positive cases, how many were correctly predicted as positive? And recall is of all the positive cases, how many were correctly predicted as positive? Yep. That's great, guys. Did that disappear? That's weird. That's the second time that's happened to me. Where a chat disappears from my window. That's weird. Lawman, I don't know if you removed that chat, but it felt like you were on the right track. I mean, I wanted to read it again, but I think you were on the right track, or maybe I deleted it with... I don't think I did. Let me know, Lawman, if you deleted that or if I deleted that. But that happened last week too. Weird. Okay, but yeah, you guys were on the right track. Very important to understand this because this is what basically tells you whether your neural network is on the right track. Do you have the right number of layers? Do you have the right number of nodes? Right? Do you need to adjust your hyperparameters? By looking at these numbers, these results is exactly what you want to do to refine your algorithm. This is how you create that feedback loop to be able to say, yeah, this is a pretty good neural network, or no, we got a lot more work to do. Okay? Diffio says, I've never seen someone streaming on so many platforms simultaneously. Thank you, I think. You know what? The technology exists, right? So why not do it? And I have enough followers on all the platforms that I go ahead and do it. So, streaming has been very good for the growth of my channel. So yeah, I guess it is a lot, but have some fun with it, right? Diffio says it's great. I just imagine the complications. There's software that helps me a lot. But it did take me a while to figure out all the components and getting it all to work and talk to each other and all this stuff. But yeah, glad you're enjoying it, Diffio. Lawman says, I recall the answer both times. I thought it was wrong. Oh, okay. Listen, guys, no, there's no need to be shy about wrong answers on my chat, right? I mean, you know, I try to tell you whether you're on the right track or on the wrong track, but there's no shame in it, right? But Lawman, from what I read, I thought your last answer was on the right track, you know? Um, Manoj says, Precision says, of the kids I gave the chocolate to, how many actually like? Yep, that's a good one, Manoj. Because you would think all kids would like chocolate, right? But you never know. Um, Ria says, "Hi, can you get me a job? I am ready to work under you." Ria, I myself am not a source of jobs. I can certainly help train you to get you a job. I do that as part of my personal coaching. So if you are interested in personal coaching, there's a link in my Instagram bio. But I myself am not a source of jobs. But I get it, guys. It can be challenging. It can be frustrating to get a job. I'm here to support you. I'm here to teach as much as I can. And if you want personal coaching, we can do that too. Okay. Recall. So Manoj, to close out his idea, says recall of all the kids who like chocolate. How many did I find and give it to? Yep. Yep. That's a good one, Manoj. Yep. Okay, guys. So again, really glad we converged on an answer. I feel like we're ready to move on here. So we've talked about the calculation side, and I always been telling you guys, oh, and then it fires, right? And then something else goes on. So this here illustrates that part of it, right? Kind of like the output part of it. And this is how you can think about it. The dial represents the calculations you're going to do. And if you land in the red zone, that's some sort of a threshold or desired outcome. So that's where your output is going to fire. Whereas if your answer sits outside of that threshold, range, answer, whatever, you're not going to fire, right? You might send off a 0 in that situation, or some sort of lowered weight in that situation. So that's what this chart, from the Tariq Rashid book illustrates. But the real takeaway here is that while the output is kind of like a 50-50 yes no, or I shouldn't say it's like a binary output, it's like a yes no true false type of output, the calculation itself is not necessarily equally binary, right? It's binary in that it's in the range or not, but that doesn't, or in the threshold or not, but that doesn't mean that the threshold is 50-50, right? There can be a lot of nuance in those thresholds. So let's talk about this. Who recognizes this? Let me know in the chat. I know all of you are very smart and capable, so I'm sure that more than just one of you is going to recognize this. What is this? What's up on the screen? So I see people on my Instagram. Thank you so much. You're welcome to stay there. You're welcome to join us on WideChat. Thank you so much for people on Twitch. I'm seeing a couple people on Twitch. I don't see anybody on Kick, but thank you so much for being here, guys. Really, really appreciate all of you. Oh my gosh, we're at an hour and a half already, guys. Crazy. Okay, so Yassine says Relu. Yassine says activation function. Okay, anybody else? You can also just choose to agree with somebody in the chat. You can just say, hey, I agree that I agree with Yassine or whatnot. Diffio says this is the step function from elementary analysis. Diffio, help me understand what you mean by elementary analysis. Help me understand what you mean by that. Or maybe you're saying that that's just your own initial take on it, right? Diffio says sorry, math background. That's okay, but just let me know what you mean by that. Khalif says Relu. Okay. Lallman says sigmoid. Okay. Manoj says sigmoid. Okay. Yassine is correcting himself and says, yes, step, not ReLU. I was wrong. Okay. Um, Diffio says, no, it's a fundamental concept in real analysis. Okay, cool. Thank you. Anna says perceptron. Okay, I like that, Anna. Um, CJ says, looks like a digital signal. It does, right? Like, I guess it'd be what? This would be like a DC signal, right? Not an AC. But I think you're right. I think it's a DC signal. Yeah, for those of you guys who don't know that, I went to a technical high school, so technically I have like this high school degree in what is it in electronics. So yeah, so we used to study stuff like this. Um, Starry Vibe says it's a tan H. Okay. Diffio says it's like the steps and prime counting function. Okay. Okay. Anybody else? Last call for answers. Last call for answers. And I'm appreciating all the answers. We're gonna come back to the actual name though, right? Anybody else? Last call for answers. What is up on the screen right now? What do you guys think? Khalif says, yep, it's step. Okay. Denelson agrees with step function. Okay. All right. So I want you to think of all the answers that we saw, right? And I want you to take a look at this one. What do you guys think? There's this one and there's this one. So two questions. Some of you said that this one was a sigmoid. Are they right? And then for those of you that gave another answer, what is this one? And if you want to go for the extra credit, what is the difference between this one and this one? And if you want to go for extra credit, talk to me like I'm a 10-year-old managing director. What do you guys think? So Khalif is answering sigmoid for the second one. Yeah, and obviously the answer is there, right? So again, two questions. For the people that said sigmoid at the beginning, what do you think about this one now? Because some of you answered, oops, excuse me. Some of you answered sigmoid for this one. And I'm not naming names, right? But what do you think about this one after seeing this one? And then for the second question is what is the difference between these two? So Diffio says both examples of nonlinear activation functions not the same. Diffio, I agree with you that they're not the same, but is it a nonlinear activation function? What do you guys think? Yassine says it has two conditions. If output is less than a threshold, then output is 0. If not, it's 1. The second one outputs a prediction between 0 and 1. Yeah. Yeah, if you look at the sigmoid function and you look at the formula over here, right, which is a pretty common sigmoid formula. I think a good number of you in the chat have seen this formula before. Right? You're going to get an answer between 0 and 1. It's a range-bound answer, right? Anna says it's discrete versus continuous. Yeah. Yep. Ty says the first one is a hard sigmoid. Yeah, sure. You could think of it that way. Oh, wow. LR. Is it LR or LRB? LRB over on Kick. Welcome. You're our first participant on Kick today. So glad to see people participating on Kick. Denelson says the difference is that the first image has a function that after a threshold, it is immediately classified as 0 if not 1. The second one has a probability prediction between 1 and 0. Yeah, okay. I'm on board with that, Denelson. So Denelson and Yassine, you guys are definitely on the right track with an answer. So if you guys want to think ahead, why do we need this? Why do we need to have a sigmoid function? Why can't everything be a step function? right? You're telling me the differences, but why? Like, give me the practical side of it. Excuse me. Anna says the step function forces values to 0 or 1. Sigmoid will give values between 0 and 1. Okay, yeah, but why? Why would you need this? Lawman says, agree with Denelson, agree with Yassine. Cool. Yeah, if you guys just want to participate in a small way, you can just say who you agree with. That's totally cool. Thanks, guys. Wael says, I think the difference is the transition is smooth transition and it is more natural than a sharp one. Yeah, but why? Why? Diffio says you can create the step function using a Fourier series, but you need an infinite number of them. Okay, cool. Yassine says for like a 10 years old answer, the first one gives straight answers. The second one gives how sure we are of our decisions or how much we learn towards an answer. The second gives how sure we are of our decisions. Okay, Yassine, there could, some people would argue that there's a name for that. Just go one step further, Yassine. You're so close. Give me one step further. Osama says step function. It gives you a discrete output. Yeah, right. We're gonna come back to that, but yes, Yassine, you're on the right track there. Denelson says amazing answer, Yassine. I agree. Yeah, so Denelson, so think about that too, though, right? How sure we are of our decisions. Yassine said that in his answer, right? There's a name for that. There's a name for that, guys. Sigmoid function output is continuous. Yep, you're right about that, Osama. It is a continuous output, range bound between 0 and 1. You can kind of see that in the formula, right? The formula itself would tell you that it's a range bound answer, right? LR says, are you streaming on other platforms at the same time? Yes, I am. I'm streaming on, I don't know, 5, 6 platforms, whatever it is. Yeah, I'm using 5, 6 platforms. I'm on 2 phones right now, but just trying to spread good content here. But thanks for joining us, Elarb. Diffio says they both give valid probabilities. Starry Vibe says probabilities, and that's exactly right. That's exactly right. How sure we are of an answer, just tell your managing director, it gives you your probability, right? So I'll tell you something that I'm working on with a current client right now. And this is an interview question that I have given and I have received in the past. What is the difference between regression and logistic regression? What is the difference between regression and logistic regression? Think about that and put your answer in the chat. I guarantee you I assure you that I've asked this in interviews, and you will probably have this in an interview. What is the difference between regression and logistic regression? CJ says the gradient is more gradual in the sigmoid function. Yep. And let's talk about that because we never really concluded on this one here. So to CJ's point, to CJ's answer, this is referred to as a step function. And there is very little nuance in this one, right? You're either at the threshold or you're not, right? It's like a very binary answer. You're either at and past the threshold or you are not. That's it, right? If you are past the threshold, you're up here at this value. If you're not, you're down here at this value. True, false, yes, no, 1, 0, right? That's all there is. Whereas the sigmoid function does allow for that nuance as you have different inputs, right? Because our x-axis is our input. So as you have a scale of inputs, not a threshold, not a set threshold, you can have a different set of values for your outputs. And then we know that we are range bound between 0 and 1 as, all probabilities basically are, right? Yeah, Lallman, I love your answer. The first one gives straightforward 1 or 0. Second one gives a probability that it is 1 or 0. Yeah. Lallman, excellent answer. That's a great answer. Diffio says regression predicts continuous values, logistic regression chooses categories. Take it one step further though. Take it one step further. Yassine says regression's range of output is not limited. Logistic regression only outputs probability scores between 0 and 1. Okay, Yassine, you have all the answers. You have all the elements of the answer. Yeah, let me come back to that, Yassine. So Denelson says regression can have values that span from infinity to infinity, and logistic regression is a binary decision model. Ooh. Oh, Denelson, you had me at span, you lost me at binary. So close, my friend. Logistic regression is a log of linear regression equation in a mathematical context. But Sravan, don't we also use the sigmoid function in logistic regression? There's a reason why I'm asking this at this point, right? Give me a 1 if we use sigmoid in logistic regression, or give me a 0 if we don't. What do you guys think? Don't we use sigmoid in logistic regression? Haven't you guys seen this formula for logistic regression? Yeah, see, I'm seeing a couple ones, right? Manoj says logistic regression predicts categorical outcomes. Often binary yes or regression predicts continuous. Yeah, Manoj, this is, everybody read Manoj's answer. That's exactly right. And Yassine, you were so close there, right? You're outputting a probability, right? That's what you're doing. You're outputting a probability. And that's the difference. When somebody asks you that question, it's a valid answer to say that regression would give you a continuous output, whereas a logistic output you would want for something that's more probability based between categories or between like a true, false, yes, no, binary type of decision, right? But that is one of the answers, to say that logistic regression gives you a probable answer, whereas regression gives you a continuous answer, right? Linear regression predicts a continuous variable, and logistic, I can't talk all of a sudden. Logistic regression predicts a probability. Yeah, that's exactly right, Starry Vibes. Yeah, you and Manoj came upon the same answer. Remember, guys, there's a reason why I'm asking this, and that's because you also use this. You use the sigmoid function in logistic regression. Yeah, in logistic regression, right? If that's news to you, then maybe, it'd be a good time to review some of your regression studies. But this is the same type of output that you would chart for most of your logistic regression problems out there, right? Because the world isn't binary. You're going to have times when you need a little bit of a different answer, right? A probable answer, right? Wael says sigmoid gives you a chance for a gray area not to be green-red. We need it to compare the model for human decision. Sigmoid gives you a chance for a gray area not to be green-red. We need that to compare the model for human decision. Yeah, I'm on board with that. I think I would say that we needed to compare the probabilities for human decisions. But you're on the right track, Well. Khalif says regression target value is continuous, while logistic is a categorical value. Yeah, I'm on board with that. I would just add that the number tells you the probability for the category, right? And by the way, this is important, guys, because a lot of the answers that you're going to get from neural networks are based in probabilities. One of the ways that you can get your outputs is you can say, let me go back to that screen. Give me just a second here, guys. So if you remember, we have an example here where we have 2 outputs, but we could have hundreds of outputs, literally, right? And one of the ways you could possibly get answers back is it'll just tell you the probability that the answer belongs in one of these classes. It'll say to output 1, I'm assigning 0.25. And to output 2, I'm assigning 0.75. Right? So it's not that it'll give you the exact categorical answer, it's that it'll give you the most probable categorical answer. And that's another way you can also kind of measure your progress. Are you getting good answers, good probabilities or not? Because let's take this one step further, guys. And this is an exercise I go through with some of my junior analysts, like my first year data scientists. Let's say I give you this problem with 2 outputs, and you've designed a model, you've done your own modeling, and you've gone away and you worked on your neural network and all this stuff, and you come back and you tell me that for some of your answers, you're getting output 1 of 0.52 and output 2 of 0.48. Is that a good neural network? No, whether you think it is or not, give me a rationale. You're one of my first year junior analysts. You've gone off. You come back to me with your results, and you tell me that in some cases, your output is going to tell you that it's this class, 0.52, and it's going to be this class, the second class, 0.48. Is that a good network? Is that a good model? What do you guys think? This is a real world problem I'm giving you guys, because this is how I train some of my first year analysts. What do you guys think? Is that a good model? So Diffio says, well, to a previous answer, Diffio says yes, but at the end of it, it gets quantized. A choice has to be made. Yes, absolutely, Diffio. And that's kind of where I'm going with this question. How do you make those choices, right? Srivan says, Dennis, in a sigmoid function, can x be a linear equation? Can x be an equation? Yes, x can represent the result of an equation. Yes, Srivan, it can. And if you read the Tariq Rashid book, it's in there where he shows that. But yes, yeah, because the sigmoid function itself only has one input, right? It has this negative x as the only input. Because if you guys don't recognize the lowercase e, that stands for Euler's number, right? So that's a fixed number. The formula itself is fixed. So yes, your x is usually derived from another formula. So yes, Ravon, great question. Yassine. Yassine, it was quick with the answer. And I think some of you are still thinking about this question because it is a little bit of a harder question. But yeah, Yassine is exactly right. If you come back to me and you tell me that this is your problem, you have 2 outputs, you can have any number of layers or nodes, whatever, right? And you tell me that this is 0.52 and this is 0.48, you're flipping coins. You're flipping coins, right? So to me, that's a weak model. That's a bad model. Because you could probably get those results just randomly, right? There's only 2 classes, right? So assuming balanced data and all that, right? I would tell you that model stinks. I as a manager would not sign off on that model, right? Because you're no better than a coin flip. You're no better than random choice. So that's why that sigmoid function and understanding the results of those probabilities is important, because it kind of helps you say, okay, well, wait a minute, like, If I only have two output classes, I better be pretty much a lot higher than 0.50, right? That's kind of like your baseline in a way, right? Now, what happens if you come back to me and you say, for your outputs, you're consistently getting 0.20 up here and 0.80 down here? How would I, as your manager, feel about that model? Well, now I'm feeling much better, right? Because now you're consistently being able to say, hey, I can distinguish the two classes because I'm showing you much higher probabilities, right? So that speaks to the strength of the model. So coming back here to the sigmoid function, when you're 50-50, you're basically here in the middle of the curve, where you're basically saying, it could be this side, it could be that side. Well, but you only have two classes, right? So you're not really strong to say, yep, you're approaching, you're approaching a high value or you're approaching zero. But if you come back to me and say, well, I'm at 0.8 and 0.2, okay, well, now you're much higher on the curve, right? Now you're much higher or you're much closer to approaching a significant output, right? So this is why sigmoid functions are kind of important in neural networks and kind of important to understand, because so much of it is based in probabilities. Yes, there are neural networks that you'll need to decide to solve this. But if you're looking at something like this, it's probably also solvable by other models, right? Like step functions are still valuable, don't get me wrong. But you can also get some of this via any other number of methods, right? All right, so I'm glad we went through that because I could tell by the answers that some of you are still processing through sigmoid and kind of like the significance of it all, because it can be very significant, right? All right. So here, what I want to illustrate is that you can also have multiple inputs. We've been talking about inputs from a fairly like kind of like a generic way, but you should realize that you can have multiple inputs. And remember that some of these inputs can actually, well, usually they represent another node, right? So when you see input A, B, and C, you can pretend that there's another node layer here that happens to have 3 nodes. Because remember, as we established last week, all nodes are interconnected, right? So all nodes connect to subsequent nodes in the layers, in the network. So here, you could assume that there's a layer with 3 nodes. What happens if that layer had 50 nodes? Well, that means that we would have to modify this graph to show 50 inputs. Because remember, all layers are connected to other layers. All nodes are connected to other nodes. So now you're taking in those inputs and you're saying, well, are we doing like, some x equals, which is basically like a threshold, right? Or excuse me, I should say like a step function. Or are we going to do something else more nuanced and do it via sigmoid? But again, the greater point here is that you're taking all of those inputs, tying it into one function, whatever that activation function may be, and then going on and doing something else with it. Okay? Everybody with me on that? So, in passing, I've mentioned weights. But now we're going to be talking about weights. Now we're going to be talking about the inputs and the weights. Because the weights is kind of like where the magic is at, right? because the weight is what actually makes the adjustments, is the adjustments that your neural network is making, right? So if you remember when we talked about regression in other times, we've always talked about y equals mx plus b, right? X being your input, and then m being the weight. Like what modification are you making to that input to give it some to generate some sort of output value, right? And that's what this is illustrating here. That we can't just say, oh yeah, there's the inputs and we put in the nodes. Well, no, we also put in weights. And the weights, like I said, is kind of like the secret sauce that the neural networks add. That's the dial that neural networks get to adjust and say, oh, that formula didn't go so well. Let me adjust the weight here. Let me adjust the weight over there, right? Kind of knock the answer back and forth into place, right? So it's not just inputs going into the nodes. It's inputs and weights going into the node, and then that is calculated or taken into account during the formula, whatever the formula may be. And as Sravan asked earlier, this X represents a combination of those weights, of those multiple outputs and weights. So even though your sigmoid threshold might only have one input, which is the X, right? Which we've already verified on this formula here. There's really just one input. Sigmoid is a fairly straightforward formula. That X itself can be made up of any number of inputs and their respective weights, right? Diffio says, in this context, X is sometimes called a logit. I love that name, easier to say than logons. Okay, yeah, sure. Yeah, guys, call it whatever you want. I'm just trying to give you guys the meta view into why we need all of these things, right? But that's fairly straightforward, right? Where it's the understanding of it's not just inputs, it's inputs and weights. All right? So let me look ahead here. Yeah, okay. So this is the last slide for today. I can't believe we've gone almost 2 hours already. So as you can imagine, so far we've only talked about individual nodes, but I told you that there's different layers and different nodes within those layers. So this is a very quick representation of what a network starts to look like, right? Where you have all these connections between the layers and with the nodes themselves. And they all have their own weights associated with each one of those inputs. And you can see here, like if we focus here on node 3, at the bottom of layer 1, node 3 is connected to the next layer to 1, 2, 3. Node 2 is also connected to 1, 2, 3. Node 1 is connected to 1, 2, 3, and so on. I don't know if it's coming across on the stream, but just so you guys know, there is a gray line. So there's a green line, a red line, and a gray line. I don't know why he chose gray. It's a terrible choice for this chart. But you can see that there's interconnection. So there's a lot of calculations happening at one time, right? And this is what we talked about, where neural networks are kind of a math hog, right? They're a resource hog because they do so much math at one time, right? We've focused on these, these example neural network structures, but there's neural networks out there that literally have like dozens and dozens of layers, hundreds of nodes per layer. So you can quickly get to these networks that are doing a lot of intense processing. Excuse me. Excuse me, my throat got dry. So this is where matrix multiplication comes into the equation, right? And I know a couple of you mentioned matrix multiplication. And it would be impossible to handle all of this without matrix multiplication. You kind of need that, right? To be able to handle all the different math that's happening, all the different sizing. Excuse me. Because remember, layers don't have to be equally sized. So you could have some layers that have 10 nodes, and then the next one has 8 nodes, and so on and so on. So really, it's impossible to handle all of these calculations without some matrix multiplication along the way, right? It would also be equally impossible for me to teach you this in a single class, right? I mean, that would be foolish of me to even attempt that, right? So I'm going to encourage you to seek out some of your own resources to understand the inner workings of matrix multiplication. Now, having said that, there is one more thing I want to cover before we wrap up. We haven't talked about frameworks. We haven't talked about the practical side of how these are actually done in the real world. And the answer is that the construction of the neural networks, the layers, the functions, the math of that is essentially what the frameworks out there do for you. So Keras, PyTorch, all of those items, that is what decides whether, or excuse me, that is what handles all that heavy lifting for you. You will not be expected to do your own matrix multiplication. You won't have to rewrite the sigmoid function or things along those lines, because that will be handled for you in the frameworks. That's kind of like the convenience that those frameworks add, okay? So this is where I want to pick up for the next class. I can't believe this took 2 hours. This is crazy. Because what I want to do is next week, we're going to do a little bit of review, and then I want to do some coding of neural networks without any frameworks. And then we're going to bring in some frameworks to help us understand how much more convenient it is with modern frameworks. Okay? So I know we covered a lot. I'm going to once again encourage you to get the Tariq Rashid book, because it's a very good book, and I'm very inspired by it. I'm adding my own work to this, but his book is very good. Next week, we're going to do a quick review, and then we're going to get right into coding. We're going to be using AI to help us code some of these collections, okay? And then we're also going to talk about the frameworks that are used in modern data science, okay? So what I'm going to need from you is you can do it today in the chat if you want, or we can do it later on, during the week. But I need you to tell me if you grew up with a father figure in the home, because if you didn't, we're going to send you to PyTorch class. But if you're a normal, well-adjusted human being, we're going to be using Keras for our neural network instructions. Okay. Oh man, as you guys know, I prefer Keras, right? PyTorch is for people who just don't know any better. But we're going to pick up on that next week, because if you feel intimidated or you feel like this is something you don't want to do, don't worry about it. A lot of the modern frameworks handle a lot of this work for you, okay? Okay, there's the chat. I wanted to make sure you guys are still listening. Diffio says lol, Manoj says lol. So, I respect that PyTorch exists. It's just for people whose father one day said that they were going out for cigarettes and they never came back. That's how you end up as a PyTorch developer, right? Let's be honest. All right, guys. I can't believe that went for 2 hours, guys. You guys are crazy. You guys are making me stream for 2 hours. Oh. Diffio says, nice content, well done. Thank you, I appreciate that, my friend. And Diffio, thanks for joining over on Twitch. I love seeing people on all the different platforms. So guys, we definitely covered a lot of stuff today. Don't feel intimidated. Neural networks is definitely achievable. It's definitely possible to learn. I'm giving you guys the fundamentals because I think these are really important to understand. And this is how we build up our skills brick by brick, right? Yassine says was missing the bullying. The bullying. Yassine, I'm giving you like gems. These are gems. You should be writing that down. You should have it in your notebook. PyTorch is for people that don't love themselves. You should be writing that down. Okay? This is not bullying. This is quality instruction, Yassine. Denelson says, always love the content. Thank you, Denelson. Always love having you around. Moo says, many thanks. Really appreciate it. Yours Ramfully. What a great name. Yours Ramfully. That's a great name. Hello, sir. This is Arjun from India. Arjun, welcome. Welcome. You're joining us a little bit late, or maybe you were just listening. That's okay. But thank you. Thank you for being here. I think somebody just retracted their message. CJ, was that you? Somebody just retracted their message. Diffio says, doing my master's thesis in AI right now. Always good to go back to basics. Yeah, cool. Thank you, Diffio. I appreciate you pitching in and keep on coming back. So for those of you who don't know, maybe it's your first time like Diffio. This series I stream on Sundays. Same time that you joined today. It's 1500 GMT or 8 a.m. Pacific, 11 a.m. Eastern if you're in the US, but it's 1500 GMT for those of you worldwide. And I might get back to streaming daily. I might have another idea for some daily streaming I might want to do. So who knows? Maybe we'll do some. Well, maybe at some point we'll get back to some daily streaming. Who knows? But yeah, guys, keep on coming back every Sunday. We'll just continue this series. I think we have at least 2 to 3 more weeks in this series, maybe more. And then I want to do a series on robotics. I think Starry Vibes had requested a series on robotics. So definitely willing to do that. I have an idea for that. If anyone else of you, what a terrible sentence. If any of you would want to suggest another series topic, let me know. I'm open to the suggestions. So let me know. Diffio says robotics on down. Yeah. I think it'll be fun to do something on robotics. I got a small idea to do. Manoj says thanks, love the content. Thank you, Manoj. Appreciate your support. Again, if you guys see that icon next to Manoj, that means he's a paying member of the channel. Really appreciate support. If that's something you want to consider, really appreciate that. Lawman says thanks, Dennis. You're awesome. Thank you so much. Appreciate you saying that. Hope you're well out there in. I think you're in Nepal, so I hope you're doing well out there. Ty says thank you, Dennis. No, thank you, Ty. Really appreciate your support. Yours Ramfully says, I'm planning to do a master's in AI. What's your idea about this, sir? Yeah, there's nothing wrong with that. I would never want to discourage someone from advancing their education. Just make sure that you keep a real world perspective on it, okay? As I've shared with you guys before, I sit down to dinner with some of my friends, and all of my friends are directors and managing directors, at some large companies. And they always tell me that. They always tell me, Dennis, I'm getting these masters in data science who don't know anything. I hire them at that level, and I want to rehire them as summer analysts because they don't know anything. They don't know anything practical that he needs on day one. So make sure you keep a practical view on what you're learning, okay? Super critical. I hear that a lot as criticism. Or yours Ramfully, I think you're a little late, but somebody else expressed that in the chat, right? That they're a data scientist, but they don't feel like they know anything. I've heard that. I have clients that tell me that, right? So yeah, just keep in a real world view on all your work, okay? Otherwise, you're going to graduate and you're going to be basically worthless, right? Starry Vibes says, big thanks, sir. You're seriously awesome. Oh, thank you so much, Starry Vibes. I appreciate that. You're awesome too. Really appreciate your continued support. Keep on coming back. Ty says NLP. Yeah, a series on NLP might be interesting. Yeah, Ty, we can talk about that. That could be interesting. Diffio says, thank you. Have a great day. Yeah, thank you too, Diffio. Nice seeing you. And again, welcome for your first time. Okay, so CJ says, Are you familiar with this book? And if you are, what are your thoughts? Hands-on machine learning with scikit-learn, Keras, and TensorFlow. Concepts, tools, and techniques to build intelligent systems. I can't say I am. I can't say I am. Sounds like a good set of tools. But you know what, guys? I know that not everybody has access to these books, or maybe your budget is a little tight. Honestly, one of the ways that I learned a lot about neural networks or the frameworks is by going to the Keras documentation. And I mentioned that, CJ, because this book is obviously kind of focused on Keras and TensorFlow, which is great, right? That's the tool set that I also use. And like I said, guys, for full disclosure, I'm also one of the I'm a moderator on the Keras mailing list. So I want to disclose that so you guys don't think I'm biased, but I am biased. I like Keras. But the Keras documentation is actually pretty good, and like Keras has built-in pre-processing tools. They have built-in tools for a lot of things in neural networks. So, the book sounds great. I can't tell you to not buy it. It seems reasonable. But for those of you who don't have access to books, don't have the money for them, go look at the Keras documentation. Go look in their help section. It's actually pretty good. It's actually pretty good. It helped me, so maybe it'll help you too. Yours Rampfully says, thank you so much, sir. Will improve my... Excuse me, guys. Sorry. Will improve my practical skills. You're awesome. Thank you. I appreciate that. Yours Rampfully, I think it's your first time, so please subscribe to the channel, like the live stream, all that stuff. Keep on coming back. Keep on coming back. I'm going to keep on teaching as long as you guys show up, so... thank you, Dennis. Always appreciate your content. Ashu from India here. Welcome, Ashu. I think it's your first time here, so welcome. Glad you're joining us. Anna says, I like your jokes. You should do more of those in the session. Oh, Anna. Anna, now I am 100% sure it is your first time here, because the regulars on the stream, if you want chat, go ahead and start typing out my rants, because Anna, the regulars in the chat know that I have a long list of people that I go after on this chat, right? So I know people like Starry Vibes, Yassine, Manoj, they already know. So they can tell you in the chat all of my rants, because I have plenty of rants. So don't you worry, Anna. But I have to find a balance between that versus teaching you guys good stuff. Because like I said, ultimately, I want to put good stuff out into the universe, good data science stuff, right? I've told you guys how much I truly believe that data science is like a learned profession. It's up to me, like, the older people in the profession to help other people, help the younger people, right? So this is me, reaching my hand back to help you guys. So I want to put out good information, right? Yeah, Osama also knows my long list of rants. So if you guys want, put them in the chat. I'm not embarrassed. I call people out all the time. I'll tell you what they are. Yeah, but Anna, this is definitely your first time, because I have plenty of things I go after. CJ says, thank you. The stream is awesome. CJ, I think it's your first time here. CJ, I think we might follow each other on TikTok. If it's the same CJ I'm thinking about, maybe I'm wrong. But let me know, CJ. Yours Rantfully says, already subscribed, sir. You'll be seeing me here often. Cool. Thank you so much. Yeah, turn on those notifications and all that. But like I said, Sundays, 1500 GMT is when I stream. So whatever time this is for you, 2 hours ago in your part of the world, just keep on coming back at that time, and that's when you'll find me. For me, it's 8 a.m. on Pacific time in the US, or 11 a.m. Eastern. But 1500 GMT for those of you that are all over the world. I'm so so grateful to have so many followers from around the world. So that's why I always publish the 1500 GMT time, so you can find it, vis-a-vis your own region or your own time zone in the world. So yeah, as I always say, because of okay, Rob's asking, I'll take Rob's question as one of my last questions here. So Rob's over on Twitch. Thank you. I think it's your first time. Thank you so much for being here. What do you think about those concepts in time learning, vibe coding, no low code? Don't you think it'll be an excuse for skipping learning fundamentals? For some people it will, but that won't make you a good data scientist, right? Look, guys, the future is going to be no different than now. There's going to be good people who do good job. There's going to be people who do a bad job, right? Whether even if you gave everybody AI tools or the vibe coding tools, there's still going to be people who are great at it. There's going to be people who suck at it. That's not going to change, right? That's just a normal distribution of talent, right? You take a group of people and they'll normally distribute. You're going to have your outstanding performers. You're going to have your terrible performers, and you're going to have a lot of people in the middle, right? The fundamentals, it's what's going to distinguish that. Whether you actually understand what you're doing, what you're going after. Can you understand when things go wrong? Can you understand how to fix your nodes, how to fix your network? Can you explain it properly? Can you talk like a human to the people that pay your bills? Right? This is why I go through some of these examples and some of these exercises. Because who cares if you're a math nerd? Anybody can do that. But can you walk into a room of managing directors and have them understand you? That's the skill, right? So same thing with like vibe coding. Okay, great. Yeah, you're good at prompting, but if nobody listens to your presentations because you suck at that, then who cares, right? So yes, all of us are going to be heavily aided in the future by AI. I've been saying that for like the greater part of the last year, but you still have to be good at it. You still have to be a human about it. You still have to be able to express yourself. You still need to have soft skills so that people will want to work with you, right? So yes, AI is going to have an impact on what we do. We're going to be heavily aided by it. We're going to be expected to do more with it. We're going to be expected to do more projects. But keep on studying, keep on trying to develop your soft skills, keep on coming back and listening to good guys like me, and you're going to get there, right? So I think there's still reasons to be optimistic, okay? Wrong, CJ. I was here for last week's stream. I just have different accounts for my phone. Okay, thank you, CJ. I appreciate that. I'm pretty good at keeping my memory with my different followers, but sometimes, I make mistakes. But like I said, so fortunate to be able to have followers all over the world. But that also makes me worry about all of you because we live in such a dynamic world, such a changing world. So please take care of yourselves, take care of your families. Thank you so much, and I'll see you next time.